Welcome to the TPC desktop video series. In this video, we'll look at doing a double proportion for the BLM Manual Survey Instruction 2009. This particular example is found on page 167 of the manual. I'm showing both the record information that we've entered as a traverse and the retrace information that we've entered as a traverse. Let's go ahead and open up that record traverse, show it over here on the left, and I'll turn off the tag for the retrace. So we can see that I've got a lost corner here at X, and around that I've got four known corners. Up here to the north at A, the west C, south B, and over here at the east D. And I've got record information recorded between each of those known corners and my lost corner X. Let's turn off that tag, turn on the retrace information, and open up that traverse. Here I've got basically the same corners, but I've added an M to some of them to differentiate between the ones I've measured in the retrace survey and the ones of record in the first traverse that we looked at. I'm going to leave this one up just for a moment. Let's highlight point T. Let's go right to our double proportion dialog. It's in the COGO menu down at the bottom. Let's go ahead and click on that. Traverse PC opens up the dialog box for doing a double proportion. And notice right off the bat, I see a note at the top that says enter all directions from existing corners to the lost or temporary corner. So all of the directions are going to be from a known corner to this lost or temporary corner. Let's start here at the top. There's quite a bit of information here. The top section is our retrace or measured information. And so I'm going to tell Traverse PC that point T is my temporary corner. Because I selected up here in the traverse view, when I open this dialog, it knows that already and it's put it in place. So I'm just going to go around the corners here, known corners, and say my existing corner to the north is AM. And Traverse PC inverses the information between AM and this temporary corner T and moves me over here to the west. That corner is CM. Again, Traverse PC inverses the information, moves me down to the next corner. The corner to the south is B, and the corner to the east is DM. So now I have all of my retrace information in this dialog box. If I didn't have those positions for the known corners, I could have entered those bearings and distances manually. It's just easier to recall the points and let Traverse PC inverse those for me. Also notice that we've got the pick button next to each one of these points. I could just as easily have picked them off the drawing by clicking here and then clicking that point in the drawing as well. Okay, so Traverse PC has now moved me down to the record section. I'm going to tell Traverse PC that my lost corner that I want to compute the position for is X. Now, I'm going to do just a couple of things to set this up the way I want it to work. One is that this particular survey happens to be in units of chains. So I'm going to tell Traverse PC that my record data is also going to be in chains. So there's a one-to-one factor between the record information I'm entering and the coordinate system of this survey. If this survey were in feet and I were going to enter chains here, this factor would be 66. So I'm able to enter whatever the record data is regardless of the units of the survey. Now, I also want you to notice there's another toggle down here that says recall direction and distance with equations. That's important because I'm going to come back over here and tag just my record traverse now. And I'm going to pull the record data out of that traverse. So for the first bearing, I'm going to type in A.X. Traverse PC goes out to the coordinates for A and X and recalls that bearing for me, but it also recalls that distance. Okay, so I don't have to do that equation twice. I just press enter, go down to the next record information, which is C.X. Again, it recalls both the bearing and distance. Now let's do B.X. And finally, let's do D.X. So again, I could have entered the record bearings and distances for each of those courses individually, but because I've already put that information in a traverse, it's easier just to recall the traverse. Now, I'm going to come down and tell Traverse PC that we're not going to compute cardinal offsets just yet, and I'm going to label this new point cont. I can put the point label X in here and actually update the position of point X if I want. So if I want to continue to use the point label X for the lost corner, I can. For the purposes of the printout we're going to look at here, or the reporting, I want to create a new point for now. And then let's hit the summary button. And let's take a look at what Traverse PC has actually computed for us in the double proportion. So let's start at the top up here. Traverse PC, that it tells me, is computing a double proportion per the BLM manual method. I'm computing the position for the lost corner X. Here's my computed position, and these are the existing corners or known corners that I'm holding. Okay. Now those of you who have done double proportions using just the lats and departures will say this looks pretty familiar. So I've got my record lats and departures that come into play. I've got my retrace lats and departures that come into play. And then of course I compute the distance factor both north-south and east-west. Out of that I come up with my true line departures and latitudes, and Traverse PC displays those for you here. Traverse PC is going to go back to those known corners, apply these true line lats and departures, and basically it's got all the information now it needs to compute the position for the lost corner. So over here on the right, Traverse PC says, here's the northing and easting for that computed corner. It gives you the inverse then, north and south between points B and AM. Again, remember that we're using the retrace positions for those known corners here. And then it gives you the inverses east and west between the known corners and the computed corner. Finally, Traverse PC comes down and says, you gave me some information about a temporary corner, so I can go ahead and give you the move data. In other words, how far am I going to move that temporary corner that you computed in the northing and the easting, and also it's going to give you a distance and direction for that as well. Okay, so that's the basic double proportion computation out of the BLM manual. Let's come down to the bottom of our report and just create an extra line down here. And then let's come back to our dialog box. Remember I told you earlier that I was turning off this compute cardinal offsets. Let's do the same computation, but tell Traverse PC that instead of just doing a grid intersection between these temporary points that I create for the latitude and departure positions of my lost corner, let's go ahead and tell Traverse PC to actually compute temporary points for those and do a true line offset for those. So I'm going to use the grid information at this latitude and longitude that I'm at, and Traverse PC is going to do cardinal offsets then from those temporary points. Let's just hit the summary button and go right over here and take a look at what that looks like. I'm going to move this over just a little bit, and let's scroll back up to where this computation starts. So this time Traverse PC tells us that doing a double proportion with the cardinal offsets. Now the whole first part of this, first half, looks the same. Okay, I'm actually computing all the same information I would right down through the true line here. The difference now is that I have this cardinal offsets information. Okay, this tells me that I had to create 2 points, a temporary point for the departure information and a temporary point for the latitude information, and that based on the position of these 2 temporary points, I've got a theta or a convergence angle that will equate grid distance with the cardinal distances that I'm interested in, true north-south or east-west. Okay? So Traverse PC then is able to do an intersect, bearing-bearing intersect, off of this temporary latitude and temporary departure point using true bearings instead of grid bearings based on these theta factors here. So I come down now and get my inverse then between the temporary departure point that I computed in my lost corner and the temporary latitude point that I computed in my lost corner. Okay. Then, for those of you that are interested, Traverse PC comes down and says, what position would I have computed for that lost corner had I just done a grid computation? What coordinates did I compute using this cardinal offset, and what difference did I really end up with? Okay. It's kind of a, if you want them to know, here it is kind of thing. So finally then we get the inverse between the corners and our computed position, and once again we get the information on our temporary corner. So we know how much to move it from its temporary position to the computed position of the lost corner. Of course, when I'm ready, then I can come back and either clear this dialog box and start over, or I can start back at a traverse, and like we did in the retrace traverse here, and whatever point I have selected when I choose COGO double proportion will be my temporary corner. It's going to take you just a little bit to get used to this dialog box. There's a lot of information here, but I can handle all the retrace information, all the record information in one place, and if I've already got some of those points in my survey, I can recall them quickly to generate the data that I need to do the double proportion computation.